Michael, I wonder if you could give us your impressions of what we just saw and mission success.
Well, it's hard to tell what we saw there. I'm not sure. I'm not sure if the gain was set or, correctly or what. We had some confirmation from the mock that they did have a thermal signature.
Yeah.
I should mention that the 9 instruments on the trailing spacecraft, the L-Cross spacecraft, were exercised on the way to the moon. In fact, we took images on the way and images of the Earth, so we're confident the instruments performed as expected. At the time of the impacts, the mothership, the Lunar Reconnaissance Orbiter, our sister ship, I should say, was about 50 kilometers overhead. They will have their first, and so they should have been seeing this with their suite of instruments. They do their first data downlink in about 2 hours or so. So we hope to have the data, and I expect we will be receiving both imaging data and spectroscopic data from the host of ground-based observatories probably within the next few hours. I think it is fair to say that within this $79 million cost cap, as I mentioned earlier, the experiment had been optimized to produce the largest possible impact plume. And so I remain confident that this is our best opportunity to date to measure the extent of water ice on the moon. Now, even though there were 9 instruments on the trailing L-Cross spacecraft, which you see going in here, they basically break into 3 categories. There was something called a flash radiometer, which should have seen the flash, and by virtue of analyzing that signal, we can make some inferences about the depth of the regolith and it's the makeup of the dirt, as it were, that was thrown up by the Centaur impact.
Right, so brighter flash means, you know, hit rock, and dimmer means it hit dirt, essentially.
Right, and actually you would want a dim flash here because that is suggestive that you hit sandy material and you want to throw up as much of that as possible, and that's easier to throw up than boulders. Then there's a suite of cameras, visible, near-infrared, mid-infrared, that provide information once we analyze the signal, once we analyze the data on the shape of the ejecta cloud, which contains both regolith and hopefully water vapor. It tells us about the dust grain properties in the ejecta cloud and provides spatial context for the spectrometers. And then finally there is the suite of spectrometers, and most of the information, much of the valuable information, will come out of the near-infrared spectrometer, which provides analysis of the chemical composition of the vapor in the regolith and any possible hydrated minerals. The big squiggles are just the electronic noise in the cameras, and so even though the data will become available to us in the next few hours from the other orbiting and ground-based assets, I anticipate it will take a couple of days before we can calibrate out the big squiggles and get into the little squiggles.
As we begin to collect the data and we analyze it, if we don't find water, is that a significant finding in itself?
It is, because of the reasons I stated earlier, excuse me, and that is because the experiment has been carefully designed to maximize the amount of material thrown up. That's by the mass of the impactor. It is the largest impactor we have utilized on the lunar surface, and by the impact angle. We went in at an impact angle of over 80 degrees, so it's basically straight on. And so if we do have a negative signal when we finish analyzing the data in the next few days, it means one of 3 things. First of all, there may be no water on the moon, although that would seem to contravene the announcement made a few weeks ago from the other spacecraft. So that leaves 2 possibilities. It means there may be water concentrations, but it's at less than the 0.5% sensitivity of L-Cross, which has ramifications, potential ramifications on the ability to extract that as a resource. And the third possibility is that the water in the frozen water in the permanently shadowed regions is not uniformly distributed, but rather is in patches, and like an old Texas wildcatter, we may have hit a dry hole rather than a wet hole.
Right.
So that's part of the reason we sent the Centaur impactor and the following L-Cross spacecraft on separate trajectories at the end, so they would impact 2 possible points. I can say that regardless of the results of this experiment, whether we have detected water or whether we have established an upper limit through a null result, the results will help advance our knowledge by constraining the current models or explanations pertaining to the moon. Like all scientific discovery, it rules out some explanations. It may advance the likelihood of others. That's just the normal process of scientific discovery and advancing our understanding of the universe.
So all indications are that the instruments were working, and no matter what we find, it's going to be important.
Indeed.